Here we're going to look at solving trigonometric problems using the unit circle. As mentioned previously, the unit circle is split up into 4 quadrants, 1, 2, 3 and 4. Here they all contain an angle between 0 and 90 degrees. Each angle that comes from the positive sense of the x-axis here in each quadrant can be represented by a similar angle in the first quadrant. So if I'm looking at the size of this angle here and I call that theta, well, in quadrant 1 theta is equal to my reference angle. If I want to take an angle in quadrant 2, for example, let's say it's 150 degrees, theta becomes this angle here, which is 150 degrees from that green line. My reference angle becomes this angle here, which has an identical value in the first quadrant. How do I find that reference angle? Well, it's just going to be this line here minus my actual angle 150. If I now switch to quadrant 3, 210 degrees, well, that 210 degrees is 210 degrees from green line here, so theta becomes this entire angle. In this case, my reference angle, which is identical to one in the first quadrant, becomes this distance here. So my reference angle, actual angle theta minus 180. If I then look in quadrant 4 and pick an angle here, let's say that 330 degrees is this angle here, and my reference angle just becomes the difference between that and the positive sense of the x-axis, which is here. So that is equal to 360 degrees minus theta. So that is how we calculate the reference angle in each of our 4 quadrants. Once we know our reference angle, we can work out our sine, cos and tan of that reference angle using the trigonometric ratios in the log tables. Then we just need to figure out whether it's positive or negative given the quadrant that that angle is in. So now we're in a position to answer some questions. Let's say you are asked to find the exact value of the cosine of 150 degrees. Well, you'd follow this strategy down below. We'd look and see what quadrant it is in. Well, 150 degrees is in quadrant number 2. The reason that's important because we can now realize that cosine is negative in quadrant 2, so we'll use that fact later on. Then we'll just look for our reference angle, where our actual angle theta is equal to 150 degrees, and the reference angle in quadrant 2 is going to be 180 minus 150, which is 30 degrees. So now we use our trigonometric ratios, which we just take from the log tables. So we look for the cosine of 30 degrees. So we go cosine 30, well, cosine of 30 degrees is root 3 over 2. So cosine 30 equals root 3 divided by 2. Okay, we work out whether that's positive or negative based on what quadrant it's in. Well, we know that for quadrant number 2, the only thing that's positive are sine values, so therefore the cosine of 150 degrees is negative. So the cosine of 150 degrees is minus root 3 divided by 2. Another example would be to look for the tan of minus 60 degrees. There's an additional problem here in that we've got a negative angle. We know that since the unit circle repeats itself every 360 degrees, well, tan of minus 60 is equal to minus 60 plus 360, which is just tan of 300 degrees. So therefore we look at what quadrant that's in, quadrant 4. Our reference angle for quadrant 4 is going to be 360 degrees minus 300, which is equal to 60 degrees. Then we use our trigonometric ratio, so we're looking for tan of 60 degrees, which is root 3. Tan 60 equals root 3. Is it positive or negative? Well, the only things that are positive in the 4th quadrant are cosine values, so therefore the tan of 60 degrees is negative, and so our answer is, for the tan of minus 60 is minus root 3. So the next problem comes when we are asked to find an angle between the 0 and 360s, where the sine of that angle is equal to 1 over root 2. Okay, so it's a bit like the old problem, but in reverse. You're told you're trying to find the angle. First thing we need to do is find the reference angle. So we're told it's a sine problem, so we're going to go to trigonometric ratios and we look at sine of the angle, and the answer is 1 over root 2 is there. So therefore my reference angle is 45 degrees. The answer isn't just 45 degrees. If they limited theta to between 0 and 90, then it would be 45 degrees. But there's another quadrant where the sine of the angle gives a positive number, so that's what we need to find. So we know the sine of the angle gives a positive number, so that's going to be quadrant 1, r quadrant 2. There are two quadrants that we're dealing with. The sine gives a positive value in quadrant 1 and 2. Okay, so we're looking at these two quadrants, and we just need to see what our reference angle equates to. So in quadrant 1, the reference angle is the angle, so theta is equal to 45 degrees, and in quadrant 2, theta is equal to 180 degrees minus 45 degrees. So theta there is going to be 135 degrees. The two possible answers to that problem are 45 degrees and 135 degrees. Now number 1 over root 2 can give you 4 different quadrants, but if it was a minus 1 over root 2, then the angles we're looking for must be in quadrant 3 and 4, because that's where sine is always negative. But because in this question we're asked for just sine of theta being plus 1 over root 2, then it had to be quadrant 1 or quadrant 2, because sine of the angle gave a positive number. Well, that's only the case in quadrant 1 and quadrant 2. So in this question we're asked to solve the equation sine of 3 theta is equal to minus 3 over 2. And we're looking for theta between 0 and 360 degrees. So we start with the same strategy. We'll find the reference angle. So we're looking for sine, and we have the answer to root 3 over 2. So a reference angle in this case is 60 degrees, or else if we're dealing with the radians, it is pi over 3. But I'll just keep it in degrees for now in this video. So the reference angle is 60 degrees. Okay, now we need to see what quadrant it's in. Well, the sine of the angle gives a negative number, so sine is negative in quadrant 3 and quadrant 4, because in quadrant 1 and quadrant 2 the sine of any angle is always positive. So here we're dealing with quadrant 3 or quadrant 4. In quadrant 3, what does 60 degrees look like? In this case 3 theta is equal to 180 degrees plus 60 degrees, and in quadrant 4 3 theta is equal to 360 minus 60 degrees, which is 300. Okay, but we're asked to find all the values for 3 theta between 0 and 360. So we're going to have to start using the general form. What we're going to do is just deal with quadrant 3 first. Now, because we need to use the general form, 3 theta is equal to 240 degrees plus n times 360. Now we need to increment n until we get to a stage where we've gone past 360. So let's solve for theta. Theta was 80 degrees, because we're dividing everything by 3, plus n times 120. Therefore, if n is equal to 0, theta equals 80 degrees. If n is equal to 1, theta, 80 degrees, plus 1 times 120 degrees, which is equal to 200. If n is equal to 2, then theta is equal to 80 degrees, plus twice 120 degrees, which is 320. There's no point in me making n any larger, because all I'll do is start to repeat the numbers, because I've gotten above 360. Now I do the exact same with quadrant 4. 3 theta to 300 plus n times 360, then theta is equal to 100 plus n times 120. Well, when n is equal to 0, theta is equal to 100 degrees. When n is equal to 1, theta is equal to 100 plus 120 degrees, which is 220 degrees. And when theta n is equal to 2, theta is equal to 100, 240 degrees, which is 340 degrees. So now we have all of the angles that are solutions to the equation sine of 3 theta equals minus 3 over 2, minus root 3 over 2, when theta is between 0 and 360 degrees.